this lesson, we're going to be talking about gases, and in the entire chapter, we're going to be talking about gases. So we've got to discuss the kinetic molecular theory, which is 4 different statements and 4 different assumptions that we're going to make whenever we talk about gases. So the first one is that gases are a collection of particles that are constantly in motion. They are constantly moving. Secondly, is that we assume that there's no attraction or repulsion between these particles. So if they collide with one another, they're not going to stick to one another. They're going to bounce off each other just like pool balls do. Okay? 3, there's a lot of space between those particles compared to their actual size. So if you were to take a gas and compress it, the volume would decrease significantly because the volume between those gas molecules is so large. So you can compress gases very easily. And finally, the speed at which those particles move, it increases when you increase temperature, which makes sense because if you're going to give gas molecules energy, they're going to start moving faster. Okay? So one term we have to talk about when we're talking about gases is pressure. Okay? Now pressure, one term that we will be talking about is atmospheric pressure. And so that's the amount of pressure resulting from the air pushing down on us. Because if you can imagine, the air above you is like a column, and it is a column which will push down on you because there's a large amount of gas above you. Now the interesting thing is if you are at a lower altitude, the pressure will be higher because there's more air above you pushing down on you. While if you're up in the mountains, the pressure will be less because there's literally less air pushing down on you. So that pressure, that pushing, results in a number of different differences that result when you're in the mountains versus when you're at sea level, which we will discuss later on. Okay? So pressure, we need to, now that we've talked about it qualitatively a little bit, right? The pressure is a force that's exerted over a specific area. So we're experiencing atmospheric pressure right now as you're watching this video. We need to give it units, of course. So units of pressure include atmospheres, kilopascals, and millimeters of mercury. All right, so 1 atmosphere equals 101.3 kilopascals, and that equals 760 millimeters of mercury. So these are the most common units for pressure for gases that you'll see in this class. So let's convert. If I give you 1,277 millimeters of mercury, and I ask how many atmospheres that is, what you need to do is you're going to write your given, that I'm going to get out of millimeters of mercury by putting it on bottom. I'm going to get into atmospheres by putting it up top. Then I know that there's 1 atmosphere for every 760 millimeters of mercury. So what I'm going to do is I'm going to divide 1,277 by 760. I want 4 significant figures in my final answer, so my final answer will be 1.680 atmospheres. And that's all there is to converting between units of pressure. The next concept that we're going to be talking about is relating pressure, the force that's exerted over an area, and volume, which we've already talked about. Now, if you think about it, if you look at this example, if I've got a gas that is within this container, okay, and its volume is 4 and its pressure is 1 atmosphere, if I have that volume, so I take it from 4 and make it become 2, my pressure is going to increase, and that makes sense because if you think about it, you still have the same number of molecules, but because you've decreased the volume, they're going to be bouncing off the walls of that container more forcefully because they've got less space to travel. So pressure and volume are inversely related. When one goes up, the other goes down, and that is Boyle's law. All right? How does this apply to our everyday lives? Well, when you breathe, what happens is before you actually bring breath into your lungs, your diaphragm is going to drop. When your diaphragm drops, that causes the pressure in your lungs to decrease. And it decreases because the volume in your lungs increases. So when your diaphragm drops, the volume increases, the pressure decreases, and because there's more pressure outside of your mouth than inside your lungs now all of a sudden, air is going to be sucked into your mouth, down into your lungs. When you exhale, your diaphragm moves up, which causes the volume to decrease, which causes the pressure to increase, which then forces the air back out. So when you're breathing in, you're not actually physically breathing in the air. The reason why air comes into your mouth is because when you breathe in, drop your diaphragm, which causes the air to immediately and naturally come into your lungs because the pressure in your lungs has decreased. So, in order to relate pressure and volume, this is Boyle's law. P1 V1 equals P2 V2. P1 refers to the initial pressure, V1 is the initial volume, P2 is the new pressure, and then V2 is the new volume. So let's look at an example of how to use this. So if I have a volume that has 30 liters of helium gas at a pressure of 103 kilopascals, I'm wanting to know what the volume is if it rises to an altitude where the pressure is 25.0. So my 30 liters is going to be my V1. My 103 kilopascals is going to be my P1. And then 25.0 is going to be my P2, and I'm solving for V2. Okay? So my P1 again is 103. My V1 is 30. And that equals my P2, which is 25.0, times V2. So when you solve this, I get V2 equals 124 liters. Let's make sure this makes sense. What I'm doing in this problem is I'm taking my pressure and I'm decreasing it, which should, because pressure and volume are inversely related, that should cause my volume to increase, and it does. So that's it. What we talked about is the concept of pressure, what it is, how we experience atmospheric pressure, the units of pressure, and then finally Boyle's law, which relates pressure and volume.